if it is OSPF, router A would have learned in the database that there are two paths to reach 2222 because OSPF learns link stated to the advertisement. The OSPF advertises link status of the link. Here, distance vector protocol advertises only the best route in the routing table. Only those best route in the routing table. So A cannot learn multiple paths, likewise router 3 cannot learn multiple paths. Two reasons. One, the best route from the routing table is advertised. Secondly, split horizon. Fine. What is next? The metric of RIP is hop count. RIP is a distance vector routing protocol. RIP uses UDP 520. Next is protocol. RIP has got periodic update every 30 seconds. The complete routing table will be advertised. This is to ensure that routes are still available. See, there is no neighbor here. In EAGRP, the hello packets are sent every 10 seconds. Sorry, in OSP, which we already saw, the hello packets are sent every 5 seconds. Am I right? No, 10 seconds. In OSPF, hello packets are sent every 10 seconds. Sent and received between neighbors every 10 seconds. That ensures that the route learned earlier from the neighbor are still available. That guarantees, the hello packet guarantees. If the neighbor is saying hello, then all the neighbor gave me is still available. We don't have such hello packets in RIP. RIP never learns neighbor. So they rely on this periodic update that comes every 30 seconds to determine to be confident all that I learned is still available. The routes are still available. 30 seconds. When a network goes down, for example, two. This advertised one hop. It learned as one hop. This learned wrote one. Four learned that 2222 is one hop in this direction. 3 will learn 2 hop in this direction. Router 2 will learn 3 hop in router 3's direction. Router 1 learns 4 hop in router 2's direction. Yeah, so this is how the routes will be learned in the routing table. If now this network goes down, okay, someone is pinging someone is pinging from somewhere, and the destination of the packet is to. When it received on router 1 will forward it to router 2 will forward it to 3. At last it pings. But what if this network goes down? As soon as this goes down, router 5 will stop telling this. Router 5 will remove the route from the routing table. Router 5 will remove the route from the routing table because it is directly connected. Router 5 knows that this network has gone down. Router 5 knows that the network has gone down. So router 5 removes the route immediately from the routing table. It can sense it that it has gone down. Line protocol went down. But router 5 will not inform this to others. Router 5 will simply stop advertising. Router 5 will not tell router 4, I found to down. It will not say that. Router 5 wants to wait. Usually every 30 seconds it used to send the update saying to do is 1 hop away. But now it will stop saying that only that much. It will stop saying. It won't say it is down. It will say it won't say anything. But the poor router 4, it still keep on saying to is 2 hop away. Even router 3 is advertising to is 3 hop away. This is advertising to is 4 hop away. This is going on as usual. This is still going on as usual. The updates are going every 30 seconds. Even though the original source is not advertising, R4, R3, R2, and R1, they continue sending the periodic update every 30 seconds as if nothing went wrong. But the network itself has gone down. Why R4 is doing this? Because it's a distance vector routing protocol. Meaning, whatever the route that is there in the routing table should be advertised every 30 seconds. That is why it is advertising it. Router 4 did not remove the route from the routing table because router 4 has got no information saying the 2222 is gone. Router 4 learned it from router 5, but now router 5 has stopped saying about it. So what router 4 does is it starts watching on this network. It starts keeping an eye on this network. Why? Router 4 is supposed to receive update every 30 seconds, but now the update is not coming. Something is wrong. Router 4 thinks that something is wrong, but it won't tell it to router 3. Router no query process. So router 4 just keeps an eye on 2222 network every 30 seconds. Router 4 is supposed to get update, but it's not getting. It keeps an eye and patiently wait for router 5 to do something. router 5 to say something. But router 5 is not going to say anything because it is gone. 222 network is gone. So this router 4 will hold it for 180 seconds. We call it as hold time. 180 seconds, router 4 is waiting to take one decision. What is that? Possibly down. It is not one hop, it is possibly down. To take this decision, it needs to wait for 180 seconds. 180 seconds, there is no hello packet. For 180 seconds, there is no hello packet. Sorry, not hello. There is no update. 180 seconds, there is no update. So I'm going to decide, I'm going to consider that this will never come again. This is gone. Router 4 decides that it is gone. But it has to say to all other 3, 2, 1 so that they need not wait for another 180 seconds. Router 4 have to save the other routers from wasting the time. See, during this 180 second, if packet would have come, it would have got dropped here. No, here. During the 180 second, router 4 would have forwarded the packet to router 5 and router 5 will drop it. So it's waste of bandwidth and process utilization on all these routers because it's going to get dropped there on router 5. So router 4, it do not want other routers to wait because router 4 has already waited. So earlier router 4 was advertising 2 hop away to reach 2222, but after discovering the network is down, it will advertise with the number 16. Every router, when they receive 16, they change the routing table to possibly down and they advertise 16. Router 2 also will change it to possibly down and it will advertise 16. And router 1 also immediately change the route to possibly down. That 16 mix signals the other router that the route is no more available. That 16 is an infinite hop. Metric of RIP is hop count. But 0 to 15 is the valid metric. For any destination, if you have hop count between 0 to 15, it is valid. 16 is an infinite metric. RIP don't like RIP 16. So router 5 did not advertise for 180 second about 2222. Router 4 was patiently waiting. After 180 second, router 4 started telling everyone, I waited for that network. Better you don't waste time. To say this, it uses number 16 metric. So it needs that time to inform everyone, I waited. You don't wait. For that, it will keep this possibly down route for another 60 seconds in the routing table. So earlier it was 180 second, it was keeping the route in the routing table. Now it is another 60 second, which is 240 second in total to flush it out. So router 4 removes the route from the routing table completely in 240 seconds. 2, 3 and 1, 2 and 3, they also will remove in 60 seconds. After learning possibly down, after receiving the packet 16 hop with a metric of 16 hop, after receiving the update with a metric of 16 hop, router 1, 2 and 3 is going to only wait for 60 seconds in a possibly down state and then throw the route from the routing table dynamically. Route came in dynamically, got removed dynamically now. So the periodic update is 30 seconds, the hold time is 180 seconds, and the flash interval is 240 seconds. Let us say the route went down and it did not reach 180 seconds. It did not reach 180 seconds, let's say 100th second. 100th second this has come up. What will happen? It will immediately trigger update, immediately inform router 4, and router 4 will reset the timer, and again every 30 seconds as the update comes, router 4 becomes normal. It won't keep an eye, it won't keep an eye on 2, just behaves normal. But after this 240 second, when this network comes up, after everyone removing from the routing table, when this network comes up, router 5 will take its 30th second to advertise. Router 4 will take its 30th second to advertise to 3, likewise 3, 2 and 1. So here we see different timers. Okay. See, 240 second depends. For those who don't have internet in their country, getting a letter in 3 days' time is normal because they don't have internet facility. For them, it is normal. But today, to get an information, if someone takes writing letter to central government about this, we are writing letter. That is not acceptable, right? Likewise. Today, network is very fast. 60 seconds itself is not acceptable. Convergence time of 60 seconds itself is too much. What is convergence time? If something goes wrong, everyone gets updated with the new info. That is what convergence time. Adapting to the change, new change. For that, if it takes 60 itself is too much. This is taking 240. After 240, it will try to learn new path. Listen. If the older path is there in the routing table, new path cannot come. The old one should go out. Only then, new route, if available, can be learned in the routing table. For example, in this picture here, this link gone down. Router A will not know that. No. According to router 3, how many paths to reach 2222? Only one path via router 4. There's only one path. But for router 3, there is also another path, only you and me know, but router 3 will not know. When will router 3 know? When this when this link goes down, and or let's say this link, not the directly connected. This link goes down, and router 3 still holds the route for 240 seconds. It holds the route. After 240 seconds only, it will throw this route from the routing table. And then it will inform router 2 saying 16 hop. Router 2 will also remove that route from the routing table. Now router 2 has got no problem. Split Horizon cannot stop router 2 advertising the route to router 3. See, it takes more than 240 seconds for router 3 to realize that there is another path like this. Because router 3 will not be informed about this new path as long as router 2 holds the path via router 3, which is down for 240 seconds. This is what called as convergence. Delay in learning the new topology. So periodic updates and the whole time and flash interval in RIP is very, very slow. In RIP, these timers can be changed, but not recommended. Why? Every 30 seconds sending the complete routing table means every 30 seconds you're going to consume the bandwidth. Every 30 seconds you're going to disturb the other routers with updates. Even though it's not a fresh update, it's the same update. 30 seconds, every 30 seconds, same update. Even though it is the same update, for the receiving router, it will open, it will process it as if it is something new. So every 30 second process utilization, bandwidth utilization. If you reduce the time to 5 seconds, what will happen? Every 5-second bandwidth and process utilization. Just for routes. This process is not utilized for packet forwarding, for understanding the path. Understanding the topology, if every 5-second bandwidth and process utilized, then the router will be always busy maintaining the routing table, not forwarding your packet. There is no processor left for your packet forwarding. So the efficiency of the network will go down because the busyness of the router makes the router tired, meaning they don't have enough processor to process our other packets. So changing the timer is not recommended. If your network is accepting this timer, then go with this protocol. Otherwise, have another option, EIGRP, OSPF, like that. RIP is an option for those who are okay with this timer. RIP, again, we saw the hop count is only 0 to 15. For one hop to 15 hop is what RIP can handle. 16th hop, even if you have a real router at 16th hop, the metric for the route with 16 hop is not acceptable. RIP cannot route the packet which is more than 15 hop or beyond 15 hop. This may all sound as a limitation, but I don't see it as a limitation. I see this is also a nice protocol. You cannot go with RD car on Verappu. Verapil செல்லும் பொழுது மாட்ட வண்டி தான் அவசியம். உங்கள் ஆடி கார் வெறப்பு வழியாக உங்களை கொண்டு செல்லாது. So for villagers, always bullock cart is the best. Likewise, in networking, there are a lot of village environment where only bullock cart is needed, drip is needed. Their OSPF or EAGRP may not suit. For example, you have a situation where the best path is needed as per the hop count, not based on the bandwidth. You don't want bandwidth to be the metric to select the path. In both EIGRP and OSPF, bandwidth is going to play a vital role. Which we don't like. We want the protocol to take decision only based on hop count, village experience. Like what? Tunneling concepts. Tunnels are one hop always. You should not focus on bandwidth there because tunnel bandwidth will be very poor because it is using physical interface. It uses the physical interface. So definitely the bandwidth of physical interface will be more than bandwidth of the tunnel. Tunnel bandwidth is going to be less. So every protocol is important. Because of this timer 240 and 180 and 30, you cannot say RIP is bad. See, inside the tunnel, which is a paid service, if you keep sending update every 5 seconds, what will happen? You will be paying only for that 5-second update, the bandwidth consumption by the update. 30 seconds is reasonable. 180 and 240 is reasonable for a tunnel environment. Right, so what we have learned is a distance vector protocol, RIP. We have few more things left in RIP. I said RIP sends update to a broadcast address. which is found to be very bad because it is sending to broadcast, which means it will go to everyone, including printers and scanners. To stop that, version 2 came, which uses 224.0.0.9 multicast address. So when any packet is sent to multicast address, only the multicast group members can open it. Meaning only those routers that runs RIP alone can understand this, open this. Even OSPF routers cannot open this RIP packets. So they don't open, they don't accept, they don't process, they don't waste time. Only the RIP routers will learn it because the RIP joins that multicast group. Not only that, RIP version 1 is a class-full routing protocol. RIP version 2 is classless, meaning you can have different subnets, subnetted networks in your organization. That is what we see everywhere, classless. So we need a classless routing protocol. So version 2 is the best option. The default version is version 1. Route poisoning means after waiting 180 seconds, what router 4 was doing, it was sending with a hop count 16 by removing the original hop 2. Earlier it was advertising 2 hop, now it is putting 16 hop. Why? In order to tell others that the route is no more available. In order to tell everyone that route is no more available, we call this route poisoning. If it is 2, it is a valid route. If it is 16, for all those routers that receives with 16, it's like a poison. Okay, so route poisoning means sending the route updates with 16 hop. Now, you all know that split horizon will not allow the route that is learned on this direction to be advertised back on the same direction. But after waiting 180 seconds, the 16 hop advertisement, which is called route poisoning, will go even in this direction to ensure that what R4 has discovered after 180 seconds is true. It goes backward. Earlier, it was not possible because of split horizon. Now it is possible because it waited 180 seconds and router 5 is not talking about that network. We call this as poison reverse. Poison reverse is going back to the original source to reconfirm that the network is gone down by sending 16 hop. Route poisoning is sending 16 hop to the downstream. Split horizon is a route learned from one port should not be advertised on the same port. Periodic update is 30 seconds. Hold time is 180 seconds. Flush interval is 240 seconds. Metric of rip is hop count. 15 is the maximum hop for a network. 16th hop is unreachable. RIP is a distance vector protocol. It uses UDP 520. We'll